Okay, in this video we want to look at circles, and in particular the equation of a tangent and the normal to a circle. First, just want to say that when we have a line and a circle together, I guess we have three options. Now, we know that the equation of a straight line is y equals mx plus c, and we know that the equation of a circle can be written as x minus a all squared plus y minus b all squared equals r squared. So where we have these two equations, or a line and a circle, what can happen is one of three things. We could see that if this is our circle and a straight line, that straight line can cut through the circle and it'll cross the circle in 2 points. And this line, this part of the line, we would call a chord. It's part of the circle. It's a line that crosses through the circle. Our second option is this yellow line. It's quite faint, but what we're saying here is that we have our circle and this yellow line just touches the circle at 1 point and 1 point only. It doesn't cross through it like the chord does, it just touches it. And this is a tangent to the circle. And the third option is this red line here, that basically the circle and the line don't intersect at all. The line doesn't touch the circle. And so if we want to find out which one of these three options is applicable, then we can simply try and solve the equation of the line and the equation of the circle simultaneously and see whether we get two solutions, one solution, or no solutions. So here's a quick example. Show that the part of the line is a chord of the circle and find the length of this chord. Okay, so basically we're saying here's our circle, okay, and I want to prove that this line is a chord. So from here to here it is a chord. Well, what we're going to do is we're going to solve simultaneously the equation of the line and the equation of the circle. So let's do that. Let's substitute the equation of the line into the equation of the circle. That's how we solve it simultaneously. So instead of 3y equals x plus 5, I'm going to make x a subject. So x is 3y minus 5. And then we're going to substitute that into the equation of the circle. So everywhere we see x, we're going to write 3y minus 5. So this is x squared is 3y minus 5 all squared plus y squared minus 6 times 3y minus 5 minus 2y minus 15. When we multiply that all out and put it together and simplify it, we get 10y squared minus 50y plus 40 is 0. And as you can see, every single term there is divisible by 10, including 0. So y squared minus 5y plus 4 is equal to 0. And that does factorize as y minus 4 upon y minus 1 equals 0. And so we can see that y equals 4 or y equals 1. Now, not quite finished there because this was these are equations with x's and y's, so we have to find the corresponding values of x. But that's dead easy. We just plug them back into our equation for the line. You could do it for the circle too, but it's much easier to do it for the line. So when y was 4, x is 12 minus 5, so x is 7. And if y is 1, then 3 minus 5 is minus 2, so x is minus 2. And so the line cuts the circle at two distinct points, 7, 4 and minus 2, 1. So you can imagine these 2 points, we now know their coordinates. And we know that it cuts at two places, it must be a chord. Now the length of that chord is simply Pythagoras' theorem that we use for that. So the difference in x is going to be 7 take away minus 2, which is 9. And the difference in y is 3. And so Pythagoras' theorem tells us that the length of the chord is the square root of 9 squared plus 3 squared, or root 90, which is 3 root 10. And so we've shown that it's a chord. We've worked out the coordinates of where the line cuts the circle, and we're able to find the size of that. This is just sort of coordinate geometry for that last wee bit. So in this next example, find the equation of the tangent to the circle at the point 2, 6. So again, let's just try and see what's going on. This time we have a circle and we have a tangent, and this is the point 2, 6. Okay. First of all, let's just double check, and sometimes you might be asked to show that 2, 6 is on the circle, and if that's the case, we simply put x in as 2 and y in as 6. And when we do that, 2 squared plus 6 squared plus 2 times 2 minus 4 times 6 minus 20, that does work out to be 0, which is what our equation says. And so we know that the point 2, 6 is on the circle. Okay. Now, if we look at x squared plus y squared plus 2x minus 4y minus 20 equals 0, the next thing we want to do is say, well, what is the centre of that circle? And the way I'm going to do that is by completing the square. So it's going to be x plus 1 all squared. Let's complete the square on the y. Sorry, take away 1. Plus y minus 2 all squared. And take away 4 minus 20 equals 0. And if we want, we can say it's x plus 1 all squared plus y minus 2 all squared equals 25. And so we can see from this the equation of our circle that A is minus 1 and B is 2. So the centre of the circle is minus 1, 2. And so I know that this point here is minus 1, 2. Okay. Now the diagram's not to scale because obviously that 2, 6 is going to be above. It's going to be up here. But hopefully this gives you a wee idea. Because what we can now do is find this radius here. And I want to use that radius as to find the gradient of the radius. I want to use these coordinates to find the gradient. And so the gradient is the rise, difference in y coordinates. So 6 take away 2 over x, difference in x. 2 minus 1. And so our gradient there is 4/3. 4/3. Now that's the gradient of the radius. And we'll come back to that later on. But if I want to find the tangent, I know that a tangent and a radius meet at right angles. The gradients, their gradients are going to be perpendicular. So if I know that the gradient of the tangent, the radius is 4/3, the gradient of the tangent must be minus 3/4. It's perpendicular. So to finish this off then, if we know that the gradient is minus 3/4, then the equation of the tangent must be y equals minus 3/4 x plus some value c. And if we look at the point 2, 6, I know that 2, 6 is on the tangent. So let's fill in y as 6 and x as 2. So that's 6 over 4, which is 3 over 2. And so we can then find out that c is equal to 6 plus 3 over 2, which is 7.5 or 15 over 2. And so we know that y equals minus 3/4 x plus 15 over 2. Or if we multiply through by 4, we see that 4y equals minus 3x plus 30. And sometimes you'll see then that just simplified to make everything sort of positive. 4y plus 3x equals 30. But imagine we'd asked him to not just find the tangent, but find the equation of the normal. So when we look at this, if we're asked to find the normal, then our diagram looks something like this. If you imagine our centre we saw was minus 1, 2, and the point P is 2, 6. So imagine it's up here somewhere. So that's a bit more like it. There's the tangent that we found the equation for. If we're asked for the normal's at right angles to the tangent. Oh, the normal is just the equation of the radius. Okay, it's this line here. This is the equation of the normal that we want to find. And we know actually 2 points on that normal. Unlike the tangent, we only know 1 point, 0.26. Here we know 2 points. And so it's even easier to find the equation of the normal. We know that y equals mx plus c. So for the normal, the gradient of the normal, we worked out in the last case to be 4/3. And again, it goes through the 0.26. So at the 0.26, let's fill in y as 6. The gradient is 4/3. And we've seen x is 2 at that point, plus c. So 6 is equal to 8/3 plus c. We get c then to be 10/3. And so filling that in, y equals 4/3 x plus 10/3. And if we multiply through by 3, just to get rid of the fractions, 3y, is equal to 4x plus 10. And we're happy just leaving our answer like that, because all the answers are all the values here are integers, whole numbers. This answer is perfectly correct, and unless you're asked to put in a certain format, this answer will get you full marks in any test or exam. So that's finding the equation of the tangent and the equation of normal. Now, just a wee recap of some things from coordinate geometry and from circles, even at GCSE level, that are worthwhile. Distance between 2 points using Pythagoras' theorem is just this. So if you x1, y1, x2, y2, it's the difference in x coordinates all squared plus the difference in y coordinates all squared, and then we take the square root of it. That's just Pythagoras' theorem. The midpoint of a line is simply the average of your x coordinates and the average of your y coordinates. So add your x coordinates together and divide by 2, add your y coordinates, divide by 2. And this can often be a useful way if you know that a line is a diameter of a circle. Then if you know that this is the diameter and you know the 2 endpoints, then finding the center point will get you the center of your circle, finding the midpoint. Gradient of a straight line, we know is difference in y coordinates over difference in x coordinates. That should be standard for us. But also a few things that are useful just to remember about circle theorems. The product of the gradients of 2 perpendicular lines is -1. Now we know that, but why is that going to be helpful? Well, because we know that the gradient of a normal and the gradient of a tangent are at right angles to one another. So their gradients will always multiply to give -1. Don't forget the angle in a semicircle is a right angle. Okay, so again, if you know the diameter of any circle and you know the center and the radius, with this radius you can know out the length of the diameter, and this will be a right angled triangle. So any problems involving a diameter could well have a right angled triangle involved. It's worthwhile knowing the perpendicular from a chord bisects the chord. Here's our chord here. If you take a perpendicular line from that and bisect the chord, it'll go through the center of the circle. Okay, there's our chord. If we bisect that chord, it'll go through the center of the circle. And finally, and this is the one that we used for finding the equation of the tangent and the equation of normal, the radius is perpendicular to the tangent. And actually the radius is just part of the normal of this circle. So here's our tangent. We can find the equation of that tangent, but then also if we need to, we can find the equation of the radius, which is the equation of the normal.